All right, again, I'll stop if they come in here. We may have people coming in to visit, but I want to start going over Chapter 9. At a minimum, we're going to have 9 and 10 done by the end of next week. All right, that'll give us one more week to try to do 11, 12, 13, and 14. Well, that's ridiculous to try to do 4 chapters in a week because that's a chapter a day. We're not going to do that. But we'll probably that last week before break, and that's the week I think of like the 5th or something like that, we will go over probably 11 and 12. All right. Then after the break, we'll go over 13 and 14. All right. So I'm on page 353, Chapter 9, using classes and objects. So the first thing we have to do is we have to talk about class concepts. Now, you're going to hear a bunch of stuff in this chapter. When you get, as you're listening to it, you might think, that's all fine and dandy, but why the heck should I do this? Because virtually anything you can do using object orientation, which is what chapters 9 and 10 are about, virtually anything you can do with it, you can do it without using object orientation. So a lot of people are like, well, it seems like a lot more work. I don't understand why we should even be doing this. All right? The bottom line is what this ends up doing is it ends up allowing you to reuse a lot more code than you could do otherwise. Now, anytime management hears things about, like words like reuse, they think we can save money. So they're typically always jump on board with something like this. But let's talk about a few class concepts. First of all, and I'm just going to take it literally from the top. All right? So first of all, what's a class? For lack of better words, it's a blueprint. All right? And that confuses people, but look at it this way, and I don't know if I gave you this example last semester or not, but let's just say I didn't. All right? So let's assume that across the street from here there was this humongous vacant lot that was 100 acres in size. And a developer came in and bought the lot and wanted to put 100 homes on it. All right? And each home would take up an acre. All right? So you put the home on there, you'd have space for a driveway, backyard, front yard, etc. So they would each one would be on an acre. All right? Well, if it was going to be a very bland neighborhood, you might have 100 houses that looked exactly the same. You don't normally see that, though, in a neighborhood. A lot of times in a neighborhood, you'll have 4 or 5, maybe even more house plats. But let's say that the person who buys this lot brings in an architect, and they create 5 different house plans. And the plan is they're going to lay these out so they'll have 5, 5, 5, 5, 20 times. You with me? And that'll be their 100 houses. And it's going to be plan 1, plan 2, 3, 4, 5. Then 1, 2, 3, 4, 5. Boom. Each one of those house plans would be a class. It's a blueprint from which you build houses. All right? So, whereas a class is a blueprint, an object is an instance of a class. In fact, the act of creating an object from a class is called instantiation. I think that's spelled right. All right. So those are concepts that you have to hear and that you have to be familiar with. Because, well, yeah, are they on the test? I don't know. I don't remember. But they're things that should make sense to you. So a class is like a blueprint. We're going to create a class tomorrow, and we're going to call the class person. And we're going to say, well, what does every person have? We're going to keep it simple. So we're going to say every person has a first name, a last name, a social security number, a height, a weight, an eye color, and a hair color. That's it. They have those 7 things. Now those 7 things, if you go, this kind of sound like variables. They are. But typically, you don't call them variables anymore. Typically, you call those attributes. All right? So those are basically class variables. And again, that's what we're going to end up doing starting tomorrow. All right? Again, just some terms. The good news is they're called methods. Those are the class methods. Now, there's going to be some stuff as we go into this. There'll be some other words and other things that you'll hear. I don't want to get too bogged down in the details right now. But at a minimum, this is what you're going to have to be able to understand. All right? And I've given this kind of lecture many times before, and a lot of times when I'm done, a person will come up to me and say, I understood pretty much of what you were talking about, but I don't see the need. I don't understand why we even have to do this. And what I'm telling you is, you don't. Anything you can do with object-oriented programming, you can do without object-oriented programming. But typically what object-oriented programming does is it allows you to get something done faster, all right, with less code. That's one of the reasons that it's popular. You may or may not realize it, but you've already been working with object-oriented programming. You may say, no, we haven't. Yes, you have. Every time you drag a button out on your screen, you're grabbing and you're creating a button object that's based off the button class. All buttons have the same properties. They might have different values, but they all have the same properties. They all have the same methods. Every time you put a text box out, same thing. Label, same thing. So you've already been using objects. You probably just didn't realize you're using objects. All right? But now we're going to start writing code. And what's going to end up happening is you're going to end up, every time you create a new class, you're going to be creating a new file. But the file, even if you create a class in a GUI program, class files end with .cs, which stands for C#, but class files do not have a GUI. Even if they're in a GUI program, they're just code. The one we'll do tomorrow, we'll set it up, and we'll just set it up as a console app, because it'll be much easier to do it that way. Sometimes when you do this too, what ends up happening is you end up writing a lot of code. But instead of writing, it's the old saying that if you're writing 500 lines of code and you're writing it in a non-object oriented language, you'll probably write about 10 functions or methods, and each will be about 50 lines long. If you write it in an object-oriented language, you'll have 50 methods, but each will be 10 lines long. So you see what we're doing is we're taking everything and we're separating it into its own unit, so to speak. All right? So those are just a couple concepts. Create classes from which objects can be instantiated. Classes by themselves don't do you a lick of good. You have to create objects based off of those classes. All right? So we'll talk about both those. Objects, again, notice where it says create properties. Well, sometimes instead of attributes, these are also known as properties. All right? And it gets confusing because there's a lot of different ways that you can set up these properties. And we're going to look at many of them. All right? If I turned jalouse after we start going over this and I said, do X, Y, and Z, you should all be able to do it, but you might do it in different ways. All right? And that's a good thing, not a bad thing. All right. Again, we'll learn more about public and private access modifiers. We'll even bring in another one, probably not until the next chapter, and that one's called protected. Hopefully you remember this from before because we've talked about it before. If something is public, all right, so if you've got a public access modifier, all right, let's put some space in here. So if you've got a public access modifier, let me hit enter a few times here. And notice I put the P in public in lowercase, must be in lowercase. All right? That means it's available not only to the class in which it was defined, but to any other class. All right, and that's an important concept for you to realize. When something is public, it's available to all. You've already used some public methods this semester, whether you realize it or not. Write line's a public method. All right? And there are things like that, and you can go and write your own classes. And what's nice about this is you can come in and you can create a class, and then you can grab that class and put it in a lot of different programs, and it'll work. All right? Now, the opposite of public, as you probably guess, is the private access modifier. And this is available only within the class in which it is right around the room defined. All right. And there's another one that's called protected. I don't want to get into that till the next chapter because that's what the next chapter is about. There's even a few other things you'll see. There's static and there's internal. We'll talk about some of those later. All right, so you don't have to worry about them right now. But it's important that you understand the distinction between public and private. In fact, what I'm going to do is I'm going to give you a sentence. Oops. This, what I'm telling you now, this is a generalization. Do you all understand what I mean? It's something that is true most of the time. All right? But I want to give you the secret to object-oriented programming, or OOP, as it's called. And there's all sorts of people who think they're funny as heck. And they're actually, there's a book out there. I saw it. I had to open it when I was in the bookstore. It's called The Poop on OOP. All right? And it's referred to as OOP. And it's been around, really, believe it or not, for over 50 years. The first object-oriented programming language was Simula 65. It was an artificial intelligence language, 65, because that's the year in which it was written. It's 52 years. All right. Some languages are totally object-oriented. This is one of them. So is Java. Some of them are object-based, like we talked about last semester with JavaScript, which means that you can use object-oriented features and functionality, but you don't have to. So in a nutshell, what object-oriented programming is it's using using public methods, all right, to modify private data. In a nutshell, that's what it is. All right. Now, saying that, can you have public data? The answer is yes. Should you ever, for any reason, have public data? The answer is no. It's not that it's illegal, but you shouldn't do it. Imagine that I was writing a payroll program and I took gross pay and made it public. That would mean that any routine could modify it. That would even mean that other programs could modify it. That could have very devastating effects. But if you make all of your data private, and if the only way that you can manipulate that data is by using public methods, then you're on your way. Now, are there such things as private methods? Yes. Private methods are usually called helper methods. So a public method may have to call another method to get something done. That might be a private method. Again, I may have given you this example before last semester. I don't remember. But it's like if, let's say Amin owes me a favor. So I say, hey, Amin, during break, go downstairs and give me another water. He's like, okay, but he doesn't really want to. Okay? And Brady owes him a favor. So he says, Brady, here. You know, I gave Amin the money. Amin takes the money, gives it to Brady. Brady goes downstairs, gets the water, gives it back to Amin, who gives it to me. Brady's the helper method in that case. I don't even have to know that he was involved, but the things got done. All right? All right. We'll learn about what's called the this reference. This means what you're currently working with. I got to watch it because I have a tendency to use the word this when I'm using the word this. And if that's, what are you talking about? It's like when you say, like, you know, this watch. I don't mean that's not the same as this. So I got to watch what I say. No, with a watch. There you go. When you create an object in an object-oriented programming language, what happens is it automatically calls what's known as a constructor. That happens automatically. If you don't write a constructor, one gets written for you. That has, what does it have in it? An open curly brace and a closed curly brace, and nothing else. But it gets called. You always have a constructor, whether you write it or the system writes it. All right? This language, and the author talks about destructors in here, most of the time you won't write a destructor. You'll almost always want a constructor. What you're going to notice, I'll show you this. This is what we're going to be building next week. Where is it? I got it up here. Not next week, probably starting tomorrow. But if you look here, all right, we're going to create this person class. We're going to have some constants. That doesn't look new. Does anything look different from right here? What aren't we doing right here? We're not initializing the variables. Because we will initialize the variables in our constructor. That's one of the main reasons for creating a constructor, is to initialize your variables. Can you still initialize them here? Yes. Should you still initialize them there? No. Because every time we create a new person, they probably will have a different first name and last name. We're going to make up social security numbers. All right? And I made that a string for two reasons for this SSN, social security number. The first reason is, I think I mentioned this to you before, any field that you're going to make that's a numeric field should only be a numeric field if you're going to manipulate it arithmetically. All right? I mean, I've heard of people who are really geeky, but I don't know of anybody who would walk into a bar, walk up to somebody and say, would you like to know the square root of my social security number? All right? Okay. So the other reason is now we can put the dashes in it if we want to. If we made it a numeric field, we couldn't put the dashes in because it would think those are minus signs. The height and the weight, integers, I mean, I don't care. You know, we could make age, we could do a bunch of other stuff. I'm keeping it simple. String for eye color and string for hair color, we're not going to check that. So if somebody says literally they have gold eyes or whatever, the program's not going to check that. What you could do is you could have a list of values with maybe 10 different eye colors and only allow those. Well, and think about hair color. All right? I mean, just go to the store and you can see people with all sorts of different hair colors, or go to the mall. All right? And then we're going to have gender. And the reason I put it in like this is, notice we have 1, 2, 3 different data types. And I wanted us to get as much experience as possible. We could put a double in there that said salary, but then that's supposing that everybody has a salary. All right? Which assumes, I would think, that everybody has a job, or they're getting an allowance, or something. So I just kept that out of there. So we're going to build this, and I haven't even created a constructor yet, but we're going to be creating what are called getters and setters. A getter is called an accessor, and I probably have given you this example before, but it's first day of class, and I say to each one of you individually, young man, what's your name? He says, my name's Amin. All right, that's a getter. I'm getting information from him. I'm not setting anything, I'm getting it. I'm accessing it. As you'll see when we start talking about databases, that's like a select statement for databases. All right? But if I decide I'm going to give each one of you different names in here, all right, and I go, no, from now on you're Bill, all right, then that's a setter. And you'll notice in here, do you notice that word is in blue? Get, set, return, and value are all in blue. Those are all keywords. Value means that I can pass in virtually anything, but it has to be a string. All right? This right here is done differently than it's done in Java. The same thing happens, but you do it differently in Java. The good news is the editor I think we're going to use for Java a year from now, or yeah, about a year from now, it writes this stuff for you automatically. All right, I just have to show you a couple buttons to click. So we're going to do that. But then notice, last name looks pretty much the same as first, except it's L name instead of F name. Same with social security number. But then notice when we get to height. I'm going to use those constants. And I'm going to say if the height is greater than or equal to 12 and it's less than or equal to 90, it's okay. Otherwise, use a default height. Because I don't want somebody to be able to put in, 1,000. What, 1,000 inches? That would mean somebody is 80 feet tall plus. You know, that doesn't really make a lot of sense. But we're not going to put restrictions in on string values, so they can put anything they want in. So we've got a restriction for height, we've got a restriction for weight, and that's as far as I got before class. All right? If we want, we can have a restriction for gender and only allow M and F. All right? A guy that I worked with, he's decided he's retired, so now he's going back to school. And he's asked me to write him a letter of recommendation, and I did. And he was laughing. He said that when he went to apply, it was all online, and he said that it came to gender. So he did the drop down. He was expecting M or F. He said there were like 16 designations. And I said, like what? And he said, you don't even want to know, because I don't know what most of them meant. And the last one was don't know, which I thought was kind of funny too, you know, but okay. And we live in a politically correct world, or what's supposed to be.
Like as if the getter's the access there, what would you define the setter as? Just getting the information?
A setter allows you, it's called a mutator, and it allows you to actually change a value. So you can't change a value with a set. Well, I'm sorry, you can't change a value with a get. You do change a value with a set. All right? I mean, look, we're still on the first page, and we're almost ready to take a break. All right? But you have to understand that terminology as we get going. All right? Because what she does is she comes in here and says, well, you might have a class called animal, and then underneath it, you might have a class called dog, and another class called cat, and another, etc. Then under the dog class, you might have a German Shepherd, Golden Retriever, etc. What you're doing is you're creating what's called a class hierarchy. All right? And that's what she gets into here. So this is on 354. There's her definition of a class. She talks about instantiation, like I did. She talks about instance variables. She says there's even another name for them. I'm out of room here. But attributes, class variables, properties. Also known as fields. Again, with all this, it depends on the book you read. Different people use different terminology. All right. I can tell you right now, see this? This is on page 355. A program or class that instantiates objects from another pre-written class is called a class client or a class user. That question exactly is on the test, except the class user part has got the underline. That's one of your fill in the blanks. So remember class user. However you put an X by it or an asterisk or fold in that page, that's on the test. Again, it's on 355 in your book. All right. So the author says here, when you want to start creating a class, what do? Okay. It says a class header or class definition contains 3 parts. The first is an optional access modifier. You don't have to say public or private. If you don't say public or private, it automatically becomes what's called internal. What does that mean? We'll get to it in just a minute. All right. Then you need the word class. Then you give it any name you want. So the author shows an example, but first they're going to talk a little bit about these. Again, probably 10 to 15% of your test is on this screen right here. You have to understand the distinction between public and private. We've already talked about those. Public, access to the class is not limited, so it can be called from the class or other classes. Private, access is limited only to the class in which it was defined in. All right, and what do we have left? Protected and internal. Protected won't make much sense until the next chapter. But let's say that I come in here and I create a class that's called animal. And then I start giving this class that's called animal. I say that all animals can speak, for example. So I write a method that's called speak. Public, void, speak. but I don't put any code in it. I just put in a curly brace here and a curly brace there. All right? Then I've got a dog class, I've got a cat class, and I've got a bird class. Now, what I can do is, and if I define stuff in here, for example, public, I want to make that public. I will. I'll say here, protected. Protected string name. If you make something protected, it's available to the class and any what are called descendants of the class. Does it make sense that dog is a descendant of animal? Does that make sense? And if I come down here and under dogs, I put in here, I don't know, terrier, Labrador, Great Dane. Anything that I define up here as being public or protected automatically is available here and here all the way down. That's what protected means. It's available not only to the class in which it's defined, these are called subclasses. Animal is a parent of dog. Dog is both a child of animal and a parent of terrier. And that's actually how you speak, how you talk about them. You can get real weird stuff, like, because I've had people say to me, okay, if I do this, does that mean that cat is a cousin? That's going a little nuts with it. But you do talk a lot about parents, grandparents, and children. All right? But if something, as it says here on the screen, if something is protected, it's limited to both the class in which it's defined and any descendant classes. All right? And then there's internal. That's the default, which means if you don't use anything. All right? And what it says there is it's limited to the assembly to which the class belongs. What the heck does that mean? When you compile your program in C#, it gets put into what's called an assembly. And if you don't say public or private or protected, it automatically becomes internal, which means it's available through the entire assembly. You say, well, it sounds a lot like private. It's similar to private. It's a little more powerful than that, but it's similar to private. Again, I'm not going to say to you, does all this make sense? But, and I know you've heard me say this till I'm blue in the face, but it's pretty important that you read this chapter and chapter 10. All right? It's probably not going to make a whole heck of a lot of sense until you do that. So, that's about as simple a class as you can make. The word class followed by the type of class. The first initial in the class name should always be uppercase, not like variables, which are usually lowercase. All right? So that class is automatically internal. That's as though we wrote internal class employee. Since internal is the default, it's very rarely, if ever, used. There's no reason to do it. All right, if I wanted to make the employee class available to other programs, I'd put public class employee. Okay. So that's fine. Put the curly braces in there, but it says this is where your methods and your variables go. Well, then they start putting in some variables. So what they're assuming there is every employee has an ID number. Employee number, whatever you want to call it. That probably makes sense. At least at many companies, when you get hired in, you get some kind of an ID number. I don't know if I don't think so. I don't think we have one here, but I do have. You guys all have a number, whether you realize it or not. All right. Notice the allowable field modifiers are new, public, protected, internal, private, static, read-only, and volatile. All right. Well, most of the time, again, most of your data will be private. All right. Here's another question that's on your next test, right there. Using private fields within classes is an example of information hiding. That's either, I don't remember, that's either a short answer or it's a true/false. I don't remember. It might even be a multiple choice, but it's in there. Just remember that information hiding, private fields. So typically then, when you come in here, now they started to create a class. So they've got a private data that's called ID number and a public method. This is, right now, when you look at this, you go, why would you ever even want to do that? It sounds like a big waste. It is, but they're going to add more to it as you go on. All right? So right now, all employees have an ID number, and all employees can respond to a welcome message. Okay? And that's all that they've got. All right. Classes by themselves, again, are blueprints. They don't do anything until you start creating objects based off of those classes. And they show here on 360, there's an example. Right there. All right. You don't have to put these in 2 lines. In fact, more often than not, you'll see it in 1 line like is shown right here. Okay? But it may or may not look a little goofy to you. It's kind of like an array because this is a class name. That's the name of the object equals new class name paren paren. What that does, again, you're going to see this in a bit. This calls what's called the class constructor. We haven't even talked about constructors yet, but that's what that does. That's creating a brand new variable called myAssistant, and that variable is of type employee. And what that means is, right now, the only thing available to a myAssistant will be an ID number and that one method, that welcome message. That's it. That's all they can do. An object only has the abilities that you give it. So, we're going to create this object, and we're going to give it eye color, hair color, etc. And we'll give it a couple other methods. Drink, sleep, and eat. But that means that that's all that person is able to do is drink, sleep, and eat. They can't burp, for example. I'm not trying to be funny, but they only can do what you give them the power to do. So if you're creating your own methods, those methods can only do what you give them the power to do. They can only access the variables you give them, and they can only execute the methods that you give them. Now, one thing about working with, if you pass, you can pass, one of you asked me the other day, can you pass an entire array to a method? Yes. You can pass an entire object to a method. Like an array, if you pass an entire object to a method, all right, you pass a reference. So any changes you make if you pass an entire object are permanent changes. Did you hear that? They're passed by reference. And the author even mentions, you can actually do this. When you do this, when you say int x, what the computer actually does is this. And you can do that, but why would you do that when you can do it like this? But you could if you wanted to. All right? Because this was one of the questions on one of your last tests. All data types in this language are objects, even simple data types. All right, again, when you call this, the author is saying, this looks a lot like you're calling a method, and you are. You are calling the employee's constructor method. All right? Now, notice what it says here. I'm on page 361, a couple paragraphs in. After an object has been instantiated, so after you create the object, you can work with any of its public methods by using the name of the object, this was myAssistant, dot, and the name of the method. You've done similar types of things with this. You've used, for example, the text property for a label. All right, where you've said the name of your label dot text equals something. That looks very similar, to some of the stuff that we're going to be doing. Because again, label is just another object. This is known as invoking the object. It's like calling a function, but in this case, it's invoking. It's really not, it is an invoking object, but what you're doing is this object is invoking that method. That's exactly what's happening right there. So this is what the author is showing you. Now, this is how main changes. Main becomes almost truly a driver. Here you're instantiating an employee object right here. Then you're able from main to call the things that were created in the object. All right? So as you can imagine, when Ethan was born, he had a different height and a different weight than he has right now. All right, let's say it's a year from now and he loses 15 pounds. If we've got the weight, then if we create an Ethan object, we'd be able to say Ethan dot set weight, and if he's 180 pounds and he goes down to 165, we could change it to 165. Does that make sense? That's the kind of things that you do in here. All right. Again, you can pass an entire object to a method. So notice, we're calling this display employee data. We're passing a worker and we're passing another worker. What are those? They're both employee objects. So we're passing whole objects here. So you have to say there the type of the object and then whatever name. Again, a worker and another worker, actual parameters, emp, formal parameter. You know all this because we've gone over these in earlier chapters. All right. Next, they talk about properties. Let's go over this, and then we'll take another break. I mean, this is dry stuff, for lack of better words. All right. It says here, frequently methods you call with an object are used to alter the value. Okay. In fact, the way that an object, this is another question, it's someplace on the test, the way that an object looks at any time is known as the object's state. S-T-A-T-E. That's on the test someplace. Might be a fill in the blank, I don't remember. But state is on there. All right? Now, the author says you could do something like this and write something called set ID number. You could do that, but that's not the way it's typically done. Okay? Instead, as the author says, C# programmers more often create properties to perform similar tasks. A property is a member of a class that provides access to a field of a class. There's some kind of a question on the test as far as what a property is. A couple things about properties. Properties are typically, as it says, they protect private data. All right? Properties, their names are used in the same way. Simple variable names are used. So you typically do something that looks like this. Does that look familiar? It's kind of what I just showed you with the thing that we just looked at with a person. All right? So, but you have to look at this. This is the most important part of this. And it's gray in your book. If I could, I'd ungray it. But you see how it's called ID number, little I, little d? When you set the properties, you can't have, it has to be a different caseness. See that? It's a rule of the language. Because you're actually doing your get and set inside of this thing. This is all right, basically it's a property getter and setter. If you put this in there, you can do this. You can set this up like this. There's two ways of doing it, but one way is if I basically leave that out, or if I put in there set and just put curly brace, then it's a read-only property because I can't change it. All right. And can you have a write-only property? Yes, you can do that too. It's not done very often, but that can be done as well. That's why I said if this is making little to no sense to you, you should read the chapter and then come back and ask if you've got questions. All right. The field that supports a property is called a backing field. I don't remember if that's in there or not. But there is something regarding getters and setters on the test. I don't remember what it is, but there's something in there regarding it. All right. And they give some examples. So if you come in here and you create another employee that's called my chef, all right, then you can say my chef dot ID number equals. You can also say my chef dot that welcome message that we had before. I can create, and not only that, I can create an array. I could create an array with 9 objects and have an object for each one of you. All right? Where I would guess your height, your weight, etc. All right? I don't think there's a person in here I know your eye color. Sorry. It says the ID number in the second one is set to 2345. The value to the right of the equal sign, all right, it's set as an implicit parameter. An implicit parameter is one that's declared and gets its value automatically. So we can do that. So main, if we look at those 4 lines, the first line that you see there in main is instantiating or creating a new employee object that's called mychef. The second one is setting the ID number property for a mychef object. The third one is writing the ID number for the mychef. And the fourth one is calling the welcome routine. So if we look at this, this is just creating the object. This is just setting the ID number. This line right here where it says this ID number equals all that right there, that's this first line that you see down here. ID number is 2345. Calling the welcome message, that's these 2 lines. Welcome from employee 2345, how can I help you? All right. Now you can also use something that are called auto-implemented properties. I want to show you these in 2 ways. First, please go look on the screen here. I showed you this, before. If I'm writing just a get and a set like this, and if I'm not doing anything special, I don't even have to do this much work. I can write these auto-implemented properties so they look like this. That's all you have to write. It pretty much is the same thing I just showed you. All right? But sometimes you see them like that. Not only that, I can make it even simpler. I can write it like this. So if I write it like this, right here, that you see in the blue, the system handles it like this. So what I'm telling you is I could have come in here where we had these, and just as an example, with this one right here. If I wanted to, I could comment all this stuff out, and then I can come in here and I can say public string fname, and then I could just put in a curly. We move this over so it lines up, and I could just write, again, I want to make sure I can grab it right out of here because I'm lazy. Copy. Oops. And I could just put it in here like this, but I'd have to change this to, actually, what I've got right there, I can just put in the get set. So what I'm telling you is this right here, that does the same thing as this does. This is just a shortcut version of doing it. I can even put it all in one line if I want. So I can, sometimes you see it put like this. That's legal too. There's a lot of ways that you can write this, is what I'm telling you. Again, when you do that, it's called an auto-implemented property. I believe that's on the test someplace. I don't remember where. And the properties themselves are known as automatic properties. All right? So they show you them right here. Notice again, she's got a video for this. So if you do get confused, her videos are typically 2 to 10 minutes long, and she'll give you some examples. Again, everybody learns differently, so if that helps you, cool. Well, we're gonna take a break and we come back. I've been grabbing this one. I'm gonna give you all the code for this. This here, and here, and here, and then we'll put in the code for Maine, and we'll take a look at all of it. So let's take a break. Let's come back at 10 o'clock, because I want to finish writing this, and I'll email it to you during the break. All right?